The National Electrical Code, or NFPA 70, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It is part of the National Fire Codes series published by the National Fire Protection Association, a private trade association. Despite the use of the term national, it is not a federal law. It is typically adopted by states and municipalities in an effort to standardize their enforcement of safe electrical practices. In some cases, the NEC is amended, altered and may even be rejected in lieu of regional regulations as voted on by local governing bodies. The authority having jurisdiction inspects for compliance with these minimum standards. Background: the NEC is developed by NFPA's Committee on the National Electrical Code, which consists of 19 code-making panels and a technical correlating committee. Work on the NEC is sponsored by the National Fire Protection Association. The NEC is approved as an American national standard by the American National Standards Institute. It is formally identified as ANSI-NFPA 70. First published in 1897, the NEC is updated and published every 3 years. The 2014 NEC is the current edition. Most states adopt the most recent edition within a couple of years of its publication. As with any uniform code, a few jurisdictions regularly omit or modify some sections, or add their own requirements. However, the NEC is the least amended model code, even with it setting minimum standards. No court has faulted anyone for using the latest version of the NEC, even when the local code was not updated. In the U.S., anyone, including the city issuing building permits, may face a civil liability lawsuit for negligently creating a situation that results in loss of life or property. Those who fail to adhere to well-known best practices for safety have been held negligent. This liability and a desire to protect residents has motivated cities adopt and enforce building codes that specify standards and practices for electrical systems. This creates a system whereby a city can best avoid lawsuits by adopting a single, standard set of building code laws. This has led to the NEC becoming the de facto standard set of electrical requirements. A licensed electrician will have spent years of apprenticeship studying and practicing the NEC requirements prior to obtaining his or her license. The deactivation and decommissioning customized extension of the electrical code standard defined by National Electrical Code was developed since current engineering standards and code requirements do not adequately address the unique situations arising during D&D activities at U.S. Department of Energy facilities. The additional guidance is needed to clarify the current electrical code for these situations. The guidance document provides guidance on how to interpret selected articles of NFPA 70, a Euro-OE National Electrical Code Euro, in particular certain articles within Article 590, a Euro-OE Temporary Power, a Euro for D&D electrical activities at DOE sites. The NEC also contains information about the official definition of HISLOC and the related standards given by the Occupational Safety and Health Administration and dealing with hazardous locations such as explosive atmospheres. Public access to the NEC is available as a bound book containing approximately 1,000 pages. It has been available in electronic form since the 1993 edition. Although the code is updated every 3 years, some jurisdictions do not immediately adopt the new edition. The NEC is also available as a restricted, digitized coding model that can be read online but not saved, copied and pasted, or printed, free of charge on certain computing platforms that support the restricted viewer software. In the United States, statutory law cannot be copyrighted and is freely accessible and copyable by anyone. When a standards organization develops a new coding model and it is not yet accepted by any jurisdiction as law, it is still the private property of the standards organization and the reader may be restricted from downloading or printing the text for offline viewing. For that privilege, the coding model must still be purchased as either printed media or a CD-ROM. Once the coding model has been accepted as law, it loses copyright protection and may be freely obtained at no cost. Archive.org and many state or local government sites allow download of the NEC without the registration that the NFPA requires. External links to both the restricted NEC online access and free public access sites are referenced at the end of this article. Structure of the NEC. The NEC is composed of an introduction, 9 chapters, annexes A through I, and the index. The introduction sets forth the purpose, scope, enforcement and rules or information that are general in nature. The first 4 chapters cover definitions and rules for installations, circuits and circuit protection, methods and materials for wiring, and general-purpose equipment. The next 3 chapters deal with special occupancies, special equipment and special conditions. Chapter 8 is specific to additional requirements for communications systems and Chapter 9 is composed of tables regarding conductor, cable and conduit properties, among other things. Annexes AI relate to reference standards, calculations, examples, additional tables for proper implementation of various code articles and a model adoption ordinance. The introduction and the first 8 chapters contain numbered articles, parts, sections italicized exceptions, and informational notes explanations that are not part of the rules. Articles are coded with numerals and letters, as A. For example 804.22, C, 3, B, would be read as section 804.22, C, 3, B, and would be found in Chapter 8. For internal references, some lengthy articles are further broken into parts with Roman numerals. Each code article is numbered based on the chapter it is in. Those wiring methods acceptable by the NEC are found in Chapter 3, thus all approved wiring method code articles are in the 300s. Efforts have been underway for some time to make the code easier to use. Some of those efforts include using the same extension in those code articles for the support of wiring methods. The NFPA also publishes a 1,497-page NEC handbook that contains the entire code, plus additional illustrations and explanations, and helpful cross-references within the code and to earlier versions of the code. The explanations are only for reference and are not enforceable. Many NEC requirements refer to listed, or labeled devices and appliances, and this means that the item has been designed, manufactured, tested or inspected, and marked in accordance with requirements of the listing agency. To be listed, the device has to meet the testing and other requirements set by a listing agency such as Underwriters Laboratories, MET Laboratories, Incorporated, Intertech Group, Canadian Standards Association, and FM approvals. These are examples of national recognized testing laboratories approved by the United States Department of Labor, Occupational Safety and Health Administration under the requirements of 29 CFR 1910.7. Only a listed device can carry the listing brand of the listing agency. Upon payment of an investigation fee to determine suitability, an investigation is started. To be labeled as fit for a particular purpose, a device must be tested for that specific use by the listing agency and then the appropriate label applied to the device. A fee is paid to the listing agency for each item so labeled, that is, for each label. Most NRTLs will also require that the manufacturer's facilities and processes be inspected as evidence that a product will be manufactured reliably and with the same qualities as the sample or samples submitted for evaluation. An NRTL may also conduct periodic sample testing of off-the-shelf products to confirm that safety design criteria are being upheld during production. Because of the reputation of these listing agencies, the authority having jurisdiction usually will quickly accept any device, appliance, or piece of equipment having such a label, provided that an end user or installer uses the product in accordance with manufacturer instructions and the limitations of the listing standard. However, an AHJ, under the National Electrical Code provisions, has the authority to deny approval for even listed and labeled products. Likewise, an AHJ may make a written approval of an installation or product that does not meet either NEC or listing requirements, although this is normally done only after an appropriate review of the specific conditions of a particular case or location. The 2008 code has user-friendly features to aid the reader in seeing changes. Revisions or additions to the articles from the 2005 version are highlighted in gray shading. Where sections have been deleted, A bullet is shown between the paragraphs that remain. Details of selected NEC requirements. Article 210 addresses branch circuits, and receptacles and fixtures on branch circuits. There are requirements for the minimum number of branches, and placement of receptacles, according to the location and purpose of the receptacle outlet. 10 important items in Article 210 have been summarized in a code book. Feeder and branch circuit wiring systems are designed primarily for copper conductors. Aluminum wiring is listed by underwriters' laboratories for interior wiring applications and became increasingly used around 1966 due to its lower cost. Prior to 1972, however, the aluminum wire used was manufactured to conform to the 1350 series aluminum alloy, but this alloy was eventually deemed unsuitable for branch circuitry due to overheating problems and potential fire risk. Today, a new aluminum wire has been approved for branch circuitry, but it is not readily available and is not manufactured below size number 8 Arubin florins. Hence, copper wire is used almost exclusively in branch circuitry. A ground fault circuit interrupter is required for all receptacles in wet locations defined in the code. The NEC also has rules about how many circuits and receptacles should be placed in a given residential dwelling, and how far apart they can be in a given type of room, based upon the typical cord length of small appliances. As of 1962, the NEC required that new 120-volt household receptacle outlets, for general-purpose use, be both grounded and polarized. NEMA connectors implement these requirements. The NEC also permits grounding-type receptacles in ungrounded wiring protected by a GFCI. The 1999 code required that new 240-volt receptacles be grounded also, which necessitates a fourth slot in their faces. These changes in standards often cause problems for people living in older buildings. Unlike circuit breakers and fuses, which only open the circuit when the current exceeds a fixed value for a fixed time, a GFCI device will interrupt electrical service when more than 4 to 6 mA of current in either conductor leaks to ground. A GFCI detects an imbalance between the current in the hot side and the current in the neutral side. One GFCI receptacle can serve as protection for several downstream conventional receptacles. GFCI devices come in many configurations including circuit breakers, portable devices and receptacles. Another safety device introduced with the 1999 code is the arc fault circuit interrupter. This device detects arcs from hot to neutral that can develop when insulation between wires becomes frayed or damaged. While arcs from hot to neutral would not trip a GFCI device since current is still balanced, circuitry in an AFCI device detects those arcs and will shut down a circuit. AFCI devices generally replace the circuit breaker in the circuit. They are required in new construction on all 15A and 20A 125V circuits to bedrooms, where most arc fault fires originate. Conduit and cable protection. In home construction, wiring is commonly allowed to be installed directly in walls without additional protection. However, in commercial and industrial buildings, wiring needs to be protected from damage, so it is more commonly installed inside conduit or ductwork made of metal, plastic, or passageways cast in concrete. While some types of cable are protected by flexible spiraled metal armor, it is more common for conduit and ductwork to be installed empty and the wire pulled in later. The NEC spends considerable time documenting safe methods of installing cable and conduit, the primary concerns being the abrading of insulation, damage to the wire or insulation caused by sharp bends, kinking, and damage due to excess pulling strain. A wire pulled with excessive force may break inside the conduit, requiring costly removal and replacement. However, a wire pulled with enough force to stretch the wire, but not break it, creates a hazard of future failure or fire. The stretched wire section will have a thinner cross-section and higher resistance than other parts of the cable, and may have damaged insulation. Breaks may form in the stretched insulation, which may not be discovered until the circuit is powered and damage from arcing or shorting has occurred. Wires must be protected from sharp metal edges of cut conduits or cabinet holes. The NEC specifies measures to protect wire insulation from damage by these edges during installation and use. For example, insulated cables may not be inserted directly through knockouts, due to the sharp edge around nearly all knockout holes. Clamping and other wire protection is often not required for plastic conduit parts, as plastic is not likely to damage insulation in contact with it. In hazardous locations, more robust cable protection may be necessary. Common conduit and ductwork protects against direct physical abuse, but is neither air nor watertight. In wet locations, conduit may resemble standard threaded pipe in appearance, with gasketed box openings to keep moisture out. Areas with potentially explosive gases need further protection to prevent electrical sparks from igniting the gases, and internal conduit gas-tight barriers to prevent potentially ignited gases from traveling inside the conduit to other parts of the building. Actual versus maximum current rating. Most commonly available circuit breakers are rated to carry no more than 80% of their nominal rating continuously. 100% rated circuit breakers are manufactured for and may carry 100% of their nominal rating continuously. Temperature rating. The temperature rating of a wire or cable is generally the maximum safe ambient temperature that the wire can carry full load power without the cable insulation melting, oxidizing, or self-igniting. A full load wire does heat up slightly due to the metallic resistance of the wire, but this wire heating is factored into the cable's temperature rating. The NEC specifies acceptable numbers of conductors in crowded areas such as inside conduit, referred to as the fill rating. If the accepted fill rating is exceeded, then all the cables in the conduit are derated, lowering their acceptable maximum ambient operating temperature. Derating is necessary because multiple conductors carrying full load power generate heat that may exceed the normal insulation temperature rating. The NEC also specifies adjustments of the ampacity for wires in circular raceways exposed to sunlight on rooftops, due to the heating effects of solar radiation. This section is expected to be modified to include cables in future editions. In construction situations where future expansion is highly likely, it is sometimes more economical to install a slightly larger diameter conduit than is necessary for the initial building construction. Larger conduit costs more, but has a greater fill rating. This may eliminate the need for additional conduit installation while maintaining the conduit's overall temperature rating. Furthermore, it is more energy efficient and often economically justified to install larger conductors than code-required minimums due to decreased heating losses and decreased voltage drop. Additionally, larger conductors than minimum allow some capacity for possible future load changes. In certain situations, the temperature rating can be higher than normal, such as for knob and tube wiring where two or more load-carrying wires are never likely to be in close proximity. A knob and tube installation uses wires that are suspended in air. This gives them a greater heat dissipation rating than standard 3-wire NM2 cable, which includes two tightly bundled load and return wires. See also, Canadian Electrical Code, IEEEC 2, PSE Law, Japan Electrical Safety Law, 2008 National Electrical Code, 2005 National Electrical Code, /rating, references. External links, free. Restricted access to the 2005 NEC Online, free. Restricted access to the 2008 NEC Online, free. Restricted access to the 2014 NEC Online, list of NEC adopted versions by state, list of OSHA accredited NRTLs. Unrestricted, free access to the NEC and other standards, as accepted as statutory law and local building codes across the United States, archive.org.